Companies today collect more data than ever in their business activities. It is estimated that 80 to 85% of data within organizations reside in semi-structured or unstructured forms. Much of that data is trapped in complex reports and spreadsheets that are used throughout the enterprise. Companies that recognize that such data, if transformed into a structured form suitable for analysis like a database, data warehouse, or OLAP cube, represents invaluable analytical sources of information. Now let's take a look at a typical spreadsheet report containing such data. This is a mortgage market survey report provided by Freddie Mac. It is published regularly on their website as an Excel spreadsheet. The report has a header containing the type of mortgage that the report is about, followed by pages of factual numeric data. Each page contains data for a number of years broken down by months. Both interest rate and discount points are reported. This representation is visually appealing and easy to read by a human being. However, transforming this data into a business analytical model has been historically difficult to automate. A typical solution would be based on scripts for extracting and transforming data found in this report. That can involve days of coding, resulting in a time-consuming, error-prone, fragile, and costly to maintain data integration project. Often small changes in data formats would require the need to rewrite parts of that code. All of these problems can be resolved using DataDefractor Solo. Now let's take a look how DataDefractor Solo works. In this example, Amy, a data integration consultant in a financial institution, uses DataDefractor Solo to normalize Freddie Mac historical data to be easily loaded into any BI tool. On the next page, Amy defines the report layout. Her goal is to isolate the rate and points data for each year and have it surrounded with context data. She specifies that there is a header, then she drills down one level. She then defines the next level consisting of vertical pages split by using a pattern that matches a 4-digit year. She drills down once more and defines the pages for the individual years using a pattern that matches the first measure column for each year. She decides to carry over the first column from this level into the next level since it contains context month data related to the facts. She keeps drilling down until she defines the lowest level that contains numeric data surrounded by relevant context. She ends up with a collection of virtual spreadsheets with a simple and identical structure. Amy zooms out to inspect the first level where border lines are drawn indicating the layout she has defined. In the next two steps, Amy defines the position of the numeric data. She then uses flexible rules that define the area for all the sub-pages. On the next page, Amy defines the dimensional model of her data. She specifies that the measures are located in the second row. Then she defines the time dimension as being a combination of the month column and the cell containing the year. Amy decides for analytical purposes she would need the month and year kept as separate attributes of the time dimension. Next, Amy needs to define the mortgage type as a product dimension to the header level of the report and selects the corresponding cell. She wants to use only the 3 words that describe the type of mortgage. She achieves this by defining a simple extraction. On the last screen, Amy can now save the schema to be reused when new data becomes available. She specifies a file name for the CSV. It is now exported as a tabular structure with rows and columns. She is now able to do analytical work with or data.